So now we are interested in the web section. And in the web section, we have a different limit, okay, of this equation. So the limit of the equation is 0, y, and to 0.015. Is it 0.0151? Yeah, 0.015. Okay. So we are going to form the equation that has these limits. Okay. So this is our 0.015. Okay. So now our variable, our slider now is sliding here. Okay. This is a y. Okay. But because of the rule that we apply, the analysis direction starts from y max. Right. So this is our y max point. Right. And this is our analysis direction. The area of interest, okay, is this now. So the area of interest is you have to include this part and this. Okay. And why? Because we have to comply the rules that we created. The analysis start from what? Y max. Okay. So again, it's the first moment of area that's confusing. Yes or no? Okay. So now for the first moment of area, you have Q y or QZ as a function of y. Right. So this is going to be equal to the Q of the flange, which is a constant. Right? This is this number over here. It's a constant. Right? Because the variable y can only go, is only sliding about what? About the web. Okay. Then you do plus Q of the web. Then this is as a function of y. Okay. Then from here, so again, the general formula that I like to do for Q in the Z direction is I like to do with depth y bar. Okay, so we'll do that. So Q Z is a function of y. So the width is 0.16. The depth, okay, let me get the picture across, then you can see clearer. I can see clearer. We will make mistake. There we go. Okay, the depth is equal to 0.02, and then we have to calculate the y bar, right? So the y bar is equal to 0.035 minus by 0.02 divided by 2. Okay, so this whole thing is for the flange. Okay, then plus next we are going to do the web. Okay, so you have 2, right? The width is 0.02. The depth is equal to 0.015 minus y. And then the y bar is 0.015 plus y multiplied by half. Okay. You realize the y bar is always 0 point something, the maximum plus y divided by 2, right? Whereas the y or the depth is 0 point. So this is your y bar, right? This is your depth, this is your width, and this is your left and right web. And you always realize that the y bar is if d is 0.015 minus y bar is 0.015 plus y multiplied by half. If you go to the previous equation that we formed, same thing, right? You can see the same trend repeating. Is that you have your what? if your depth is 0.035 minus y, then the other one is 0.035 plus y times half. Okay, so the depth is minus, the y bar is plus half, whole thing multiplied by half. Okay, so easy for you all to remember. Oh no, where is this value? Okay, now this only works if you apply all the 4 rules. Okay, if you don't, you can, there's different way to find y bar. Okay, if you use other rules, then this might not stand. So from here, this will be equal to 0.035 minus 0.02 divided by 2 times 0.02 times 5.16 is equal to 80 times 10 to the power minus 6. And then you have plus. So it's still 0.02 because the 2.5 cancel off. So this will be equal to 0.015 squared, which is 225 times 10 to the power minus 6 minus by y squared. Okay. So this is 80 times 10 to the power minus 6 plus by 225 power minus 6 times by 0.02 is equal to 4.5 times 10 to the power minus 6 minus by 0.02 y squared. Okay. So finally, you will get 84.5 times by 10 to the power minus 6 minus by 0.02 y squared. So unfortunately, I don't know how to check that is correct or wrong. Okay, there's no way that wait, is there any way you could check? Yeah, there's no way you could check whether, wait, I think there's a way. Yeah, there's a way that you could check. If you plug in y is equal to 0.015, okay, if you plug in this is equal to 0.15, so this will be equal, or y, not y bar, y is equal to 0.015. So 84.5 times 10 to the power minus 6 minus by 0.015 squared times by 0.02. This is 4.5 times 10 to the power minus 6. You should get what? 80 times 10 to the power minus 6. Okay. So this 80 should be the same as over here. Okay. So if you use this formula again, right, you plug in 98 times 10 to the power minus 6 minus by 0.08 multiplied by 0.015 squared. Okay, you should get the same. You should get, okay, squared times by 0.08. So it's equal to, so 98 times by 10 to the power minus 6 minus by 18 times 10 to the power minus 6 is equal to 80 times 10 to the power minus 6. There you go. You just check that your equation over here is correct. It's also 80. Okay, what I just done is I've calculated the area at the intersection of the what? At the intersection of the flange and the web. Using 2 separate equations, the answers are the same. You are good to go. Okay. And then finally, the shear xy. So this is just matter of plugging in formula again. 5.813. And then the equation. Now be careful, okay? I tend to make the mistake down here also. You have to include the left and right. Okay, where? So this will become 90 power 3 divided by 5.813 power minus 6 divided by 2 divided by 0.02 times by 84.5 power minus 6 is equal to 32.707 times 10 to the power 6 minus times by 0.02, 7.741 times 10 to the power 9 y squared. Okay. So now if we were to sketch this, okay, we're going to sketch the distribution. Okay, so this is our, okay, so we're going to sketch this now. I'm going to eyeball this. And I'm going to use green. Okay, so let's pretend that this is our centroid. Okay, let's pretend, okay? And then you have your y. Okay, so this is your shear xy. So we have 10, 20, 30, and 40. Okay, so we will have our, this is our 35 millimeters, and over here will be our 65 millimeters. Okay, and then we're going to see a peak at 32.707. So we have this is where your tau max is. Okay, so at this point, right, this is where we have 32.707, and it's 0. Okay, then we have our, we calculate some points. So how this graph will look like is this. Okay, it will come to here, it will stop. Okay, and then it will be a straight line up to here. Okay, and then it will do a curve thing like this, and then it will come down. Okay, so this is how the shear stress distribution look like. Then you have to calculate what is this point. We calculate last week already, not last week. Yeah, we calculate over here. That point over there is our point 30.965. Okay, so 30.965. No, so I have to like, sorry. So this is our 30.965. And this is at 0.015. Right? And then this point, we did calculate this point also. I think we did, because it is the lower value one, right? So down here is our lower value. Did we calculate it? Or maybe not. Okay, maybe not. Okay, so this is our lower value. So this is based on thickness is equal to 0.16. Right? So on when your y is at 15 millimeters, right? You have two values, right? You have one based on the thickness of 0.16, and the other one is 30. You know what? I can calculate. So 30.96, 30.965 times by. Wait, let's not do that. Okay. So I was asked, why did we not use 0.16? Okay, because it is the lowest value. No point finding the lower value. So this is how your shear stress distribution will look like. Okay, so I'm going to end my lecture here. I see you guys on Friday. By the way, I have already uploaded homework number week 4. Okay, so for the term test, you have to do until homework 4. Lucas, yes.
I thought this equation was only valid for y between 0 and 0.01.
Yep. So this equation that I just plot is your shear xy. is equal to 32.707 times 10 to the power 6 minus by 7.7141 times 10 to the power 9 y squared. This part is from the previous equation. Is from, pardon me, it's from this equation over here.
Also above the y, the x-axis.
Yeah, so there you go.
Oh.
So this one is for this equation. You get what I mean? Okay, so
Yeah,
because of
yeah.
the limits, there you go. Okay.
Okay.
Now the other side, this will be continuous. Okay, so probably we'll continue in class. At the bottom, we form the equation at the bottom. It will look exactly like this equation.
So for the web, could we have found the distribution by going below the centroid too?
Below the centroid?
Yeah.
For the web, yes.
Oh, okay.
The answer will be the same, but not for the flange.
Yeah, not for the flange.
Okay. Thank you. Samuel.
We're testing the formulas. How did you get the y values? Like, how do you know which y values to use?